All right, go turn on. All right, let's open with some prayer. All right, God, we thank you for another day to breathe, God, another day to live, and another day to learn. God, I just ask, Lord, that you would give us clarity and you would give us a good memory of the things that we need to grasp today. God, I thank you for being with us all. In Jesus' name, amen. Okay, so we're going to turn to page 44 in the textbook. And let's see, wait a minute here. Okay, hang on a minute. Whoa, hold on. 1 through 4. All right, no, we're not going there first. My bad. We're going to start on section 1.5. All right, now, if you will, turn to page 25. See what? This is strange here. Yeah, that's what I'm looking for. That one there. Okay, now in section 1.5. If we were solving equations on page 25, we would be using the real number system. All right? Have I got that? We'd use the real number system. What's happening in this section is that instead of using the real number system, they're going to change and use some restrictive systems. And as a result of that, it's going to change the answers that are possible. All right, have I got that? So not all the answers that you might normally get are going to be possible because the domain, the values of x, are going to change based on the number system. Now, before we get to that, I want to talk about notation. All right, that's going to be the first thing that you've got to recognize. All right, normally in the past, we would say x equals 4. All right, and that's been okay. From now on, we are going to use an S, which stands for the solution set. All right, so you're not going to say x equals, you're going to start with an S for solution set. And so you're going to say the solution set equals, and then you're going to make a set. All right, now, brackets are really simple. Brackets is an S followed by a backwards S, or an S followed by a 2. Make a bracket. Try it. Try it. It's an S followed by a 2 or an S followed by a backwards S. All right. The other one, if you start with a 2 and then do an S, you got the other side. Now, it takes a little bit of time to practice that, but it won't take you long to be able to get those down. Okay? Now, so that's what we're going to do. So now the solution set is going to be the numbers in it, and if this were the case, I would have the solution set is 4. Now, the question is, what are the numbers inside here? That's the possible values of the variable in that particular problem. Okay, that's not hard. Okay, now, what happens? Let's say that I have this. As I say, the absolute value of x is equal to -7. What's the value of x that works?
7.
Absolute value 7 is positive 7. That doesn't work. Is there any answer that works? Class? No, there's no answer that works. All right, so do I say x equals 0? No, because 0 is a number, right? What happens when there are no values inside here? You write the null set, which is a 0 with a slash line through it. Okay, now this next part is very important. I'll just use those two. All right. This is a set of symbols. That is the null set. If there's nothing you put in it, you don't use the brackets, you just write null set. If you put the null set symbol inside the brackets, you're giving a set of symbols. That is an incorrect answer. Now, last year in Algebra 1, we said no solution. Now, what would you say? No solution. Null set. All right. If there is a solution, then you're going to put, now, let's say that I give you this. Let me show you a little bit different. All right, there's an inequality. What does it say? It says x is greater than 3, right? So it's all x's such that x is greater than 3. That's how that would be written. We'll get to that eventually. When we have domain and range, that's going to come back into play. But for today, and what we're doing, you need to understand the null set. All right, that's the first thing. So everybody in your notes, make sure you have null set, and then the 0 with the line through it, and you may want to add no brackets if no answer. I don't know why I'm going to have to check my length here. Okay, yeah, so that's the first part. Now the next thing that I want to talk about is that binomials equal 0. Okay, if you have these two binomials and they equal 0, if these two numbers are multiplied together and they equal 0, one or both of them has to equal 0. Agreed? All right, so what happens, you have x plus 2 equals 0, and you have x minus 5 equals 0. If you solve those equations really quickly, if I solve those two equations for x, I find that x equals -2 and x equals positive 5. So the solution is the set 5, -2. Closed set. That's how we answer. Just different, right? Just different. All right? Okay, so that's the first part. Now I want to take this and do it backwards, because that's the Algebra 2 skill. So we're going to say that the solution set is the set of numbers 1, -3, 2/3, -1/2. 4 answers. Okay. We got that far? Now, that says that x equals 1, x equals -3, x equals 2/3, and x equals -1/2. All right? This one's pretty simple. How do I make this equal to 0? What do I do with the 1 to move it over to the other side? Somebody tell me, what do I do with the 1 to move it to the other side? Subtract 1. So this becomes x minus 1 equals 0. What do I do with the second one? Add 3. So that says x plus 3 equals 0. There's my binomials. Now, the next one, I got to get rid of the 3 first. How do I do that?
Divide both sides, or multiply both sides.
Multiply by 3, right? Which will be 3x, and then I subtract the 2. 3x plus 2 equals 0. And when with the last one, how do you get rid of the 2? Somebody tell me. Multiply by 2, and then add the 1, and that will be 2x plus 1 equals 0. And those 4 things are the binomials that were multiplied together in the original problem. That gave me a solution set of those 4 numbers at the top. All right, and so if I multiply those 4 things together, I would have a polynomial of degree 4. Because that's going to end up being x to the 4th power. Okay, now, those are the things that are part of where we're headed. So in this chapter 1, that's several things that you've got to do. All right, now, in this case, if all of these equal 0, how do you make this binomial equal 0? Let's talk about it mathematically. What's the first step? Subtract 4, then divide by 3, so that's negative 4 over 3. Right? How do I make this one equal to 0? I add 9 and positive 9 over 2. How do I make this one equal to 0? Subtract 1 divided by 5, negative 1/5. That's how they get there. All right? And now, this one. To go back the other way, if the x is here, I multiply by 9 and say 9x plus 2. Multiply by 3, 3x minus 5 to move it to the other side. 12x plus 7. Okay? So, what is this one as a binomial? Clear the denominator first.
3x plus 4.
3x plus 4. Everybody see it? All right, any questions? All right, what about that one?
2x minus 7.
All right, so you're getting it. You didn't have to be quiet. Everybody else get a chance too. All right, what about this one?
5x plus 1.
5x plus 1. See it? Okay, so the same type of one-step algebra problems that we were working with, now we're working the same steps, only we're not trying to get x, we're trying to undo what was already there. Okay? Does that make sense? Is that beyond possibility of figuring out? No, it's just another step, it's another part of Algebra 2 that is completely different, but it stands alone. How many can do that? Then we're good. That's the point. If you can do that, you can do that. All right, now, the other thing that we want to talk about in this chapter is an extraneous solution. All right, sometimes in order to solve things, when you multiply in order to simplify, or when you square something in order to simplify, you may actually come out of the number system into another number system. All right, so when you are finished, you have to check your answers. All right, now, so number 3 on page 25 says this: if you have 2x plus 3 equals x minus 1, if I subtract an x and I subtract the 4, I get x minus 4. Now, that is only correct for the answer, but not given this number system. So, are there any positive numbers that will satisfy this equation? The answer is no, and so we write the null set. Not this. We write this because we're talking about the empty set. All right, now look on page 25 in your book. Now, page 25, problem number 7, it says, here is equation for A, and it's in the rational number system. Right? So, if it were in the real number system, how would we solve this problem? We would first subtract x and get 3, and then we would, you know what? I had to do a trick here, that's why. Hang on just a second. In order to get that negative sign to show bigger, I've got to say 1 minus. Otherwise it's only that big. But I forgot to take it off. Okay, so then when I subtract 3, I get 3x equals negative 11. Divide by 3, I get negative 11 over 3. Now that's the answer. Right? And then if we were in Algebra 1, this is what we would answer. However, in Algebra 2, they're going to change from the real number system to rational numbers. Now, if you don't know what rational numbers are, you're in trouble again. All right, what are rational numbers? What's a ratio? It's a fraction. So rational numbers are positive or negative numbers that can be fractions. All right, does that apply?
Yes.
Okay, so therefore, the answer, the solution set in the rational numbers is one number, negative 11 over 3. All right, now, what happens if I change to the integer system?
It's not a whole number.
Right? In the integer system, the answer is still this, but it's not an integer, and so the answer is the null set. All right, that's what that chapter is doing. Okay, so you're doing two things. Number one, you're doing the algebra, but then you're restricting it, not the whole real number system, but now a segment of numbers based on what these things mean. That's why you've got to know what those things mean. Okay? Questions about section 1-5? Just work now, okay? Good. Now let's look at 1-6. Now I've tried to set you up for this in Algebra 1 so that this shouldn't be as hard. All right, in 1-6, if you turn to page 31. All right, now, in example 6, which actually starts on the other page, on page 30, we find that x, on the bottom of 30, that x is less than or equal to 6 and greater than or equal to negative 8 over 3, which is a little bit less than, a little bit greater than negative 3. Negative 3 would be negative 9 over 3. So it's between negative 3 and 6. All right, now, top of the page, if the number system is positive numbers, then can you go on the negative side? No. All right, is 0 positive? It's neither positive nor negative. So therefore, we have an open circle on 0, and we're going to have all of the real numbers from greater than 0 up to and including 6, because it says x is less than or equal to 6. Now, if we go to integers, we can't have fractional parts. So the same information for integers is I'm going to start with all of the numbers that are greater than negative 3 up to and including 6, and that's why I have dots on the whole numbers, because whole numbers are integers. All right, so again, if we were just graphing this, we would have had from the whole place. actually, based on this, would look like that if it was graphed. That's in the real number system. And then the ones on top of 31 are in the positive integer system, or positive number system and the integer system. Okay, now we're not worried too much about that, although you're going to do some problems on page 32 where that's what you're going to be doing. Okay, so let's talk about problems on page 32. What's the first thing you have to do? Starts with S. First thing you have to do is solve it in the real number system. That means you're going to do the math. All right? You're going to solve in the real number system, and real is an R with two lines on it. So you're going to solve it in the real number system. Then you're going to determine what restrictions does the number system that you're given, what does it do to the real numbers? Okay, so on page 32, problem 4 is real numbers. So is there any change? No, no change. All right, what about 5?
Yes.
Integers, therefore it's going to look like the lower of those two lines on the previous page. All right, what about number 8? Real numbers, not going to be any change. You're going to do the math. All right, what about 11?
It's gonna be above 0.
So we're going to have an open circle on 0, and we're going to go to the positive side, and it's going to be a solid line. And then what about 14? Okay, all right, now, okay, 32, just above 15. E is an element in the set of real numbers. That's another way of, that's a more correct way of writing the directions above it. The second, B, says E is an element of integers. And the third one says E is an element of positive numbers. All right, so in problem 16, you're supposed to solve that for X, and then you're going to write 3 graphs. One for real, one for integers where you're going to have dots, and then one for positive numbers where you're going to have an open circle on value of 0, and then go to that. Does it make sense? Okay, that's what those are. Turn to page 34, top of the page. Now, let me pull this here. I think I've got this. Oh, here's something else also. For vocabulary, this is called a discrete graph. The answers are discrete because they are individual dots. It's not a solid line. So that's a vocabulary word that you might see later on. Okay, now there's 2 things on 34. One is transitivity, which you should know. For order, it also works. If X is less than Y and Y is less than Z, then X is less than Z. So the transitivity property of equality also works for inequalities. Right now, the bottom of the page is called the trichotomy. All right, there are 3 possibilities if you have 2 numbers, X and Y. It's one of these things. Either X is equal to Y, X is greater than Y, or X is less than Y. Right, and for some reason they think that's important. Right? It kind of makes sense, right? But if you have 2 numbers, 2 letters, X and Y, then either they're going to be equal with each other, or one will be larger than the other because they're not equal. Right? And that sets up your your greater than or less than inequalities. All right? Okay, so that takes care of that one. And let's see, exercise 7. I want to get to that. All right, let me ask you this. You were supposed to memorize reflexive, symmetric, and transitive. Okay, in the reflexive, if you are proving something and you want to introduce a letter or a number, that this is always true, x equals x. All right, and a lot of times what happens, if I have x plus 5 equals x minus 7. What I'm doing when I subtract x from both sides, I'm really taking this. I'm taking the reflexive property x equals x, and then I am subtracting these two equations, or I could say this, negative x equals negative x, and I can add these two equations together. In which case, when I simplify, I end up with 5 equals 7. So, 5 equals 7. All right, what do I know about that particular relationship? What's the solution set? We learned it this morning. It's the null set. There's no solution to that because 5 doesn't equal 7. All right, so the reflexive property is one that's used in proofs a lot. The symmetric property, if the x is not on the side you want it, you can switch both members, the left member and the right member, around and get the x where we want it. Now that works when you do okay, if I said 20 equals 4x and I did the math correctly, what will the next line say?
X equals.
No, it'll say 5 equals x. Because the 20 is divided by 4 and the 4x is divided by 4, but that's not what I want. And so the reflexive, the symmetric property says that I can switch these around and answer it that way. That's the reason for having the symmetric property. One of them. Okay, does that make sense? Because technically what we do is we skip this and do it in our head. Right, but know that what you really did was you had a step that you skipped. All right, now, talked about the trichotomy. If x and y is real, then it's either equal, greater than, or less than. All right, now, all right, page 39. All right, we're going to look at some properties now. I'm going to sit down and all right, first thing, I want you to write this. You're going to write this. This is problem 7. It says, prove that the multiplication property of equality states that you can multiply both members by the same number. Okay, if you're given that x equals y, and I write the reflexive axiom that says x times z equals x times z, right? That's always true, right? The second line is always true. The first line was given. Then if I substitute for z, y, I have x times z equals y times z, and that is the multiplication property of equality. I've taken the x times y and I've multiplied them by z. But it was proved with a different set of rules rather than just saying that's the multiplication property of equality. All right, now, the reason I gave that to you is that that's not obvious to me. All right, and the fact that we did not do a lot of these things in Algebra 1, and so we're not really versed on it. So now let's look at 13. Okay, what do you notice about problem A in 13A? What does that look like? What's the identity property of multiplication say? The identity property of multiplication says x times 1 over x equals 1, right? Isn't that what that is?
Yes.
Except how is it changed? Does it say x times 1 over x?
It's X, oh, but it equals the exact same thing because it's XY.
All right, okay, so you've got some commuting in there because the fraction is first, and the value of x was redefined as the product xy instead of just x. But is x times y a unique number? If x and y are real, then x times y is unique. And so it doesn't make any difference, it's still a variable. All right, so that's what that's looking at. All right, what happened in 13b?
They succeeded. They added it.
All right, what did they do to make those big brackets? You notice they associated? They associated the first two, and they multiplied both sides by 1 over y. So that's the multiplication property of equality. All right, in C, what happened? Do you notice they split apart the small xy? Because that's just multiplication, right? The four numbers that are multiplied in B are the first fraction times x times y times the second fraction. And so all they did was just associate them differently. Right now, turn the page. All right. In D, the 1 over y times y was changed to be 1 because what is 1 over y times y? That's the inverse property of multiplication, and it equals 1. So the 1 replaced its other member in the property. All right, so now we have D. All right, what changes between D and E? How come that 1 disappeared?
Because it equals the same thing.
It's the identity property. 1 times x equals x. All right, so instead of having 1 times x, or in this case, a bracket times 1, we can just say it's the same as the bracket, and the 1 can disappear. Right? So what they're doing in this problem is that they're using the properties of multiplication from those Katie properties. And they're doing that to simplify these particular problems. And eventually they get all the way down to 1 over x times y is equal to 1 over y times 1 over x. And that tells you that if you have two factors in the bottom, you can split them. Right? But that's the proof of it. Okay, now look at 14. Look at 14. All right. 1 plus 0 equals 0. All right. If 0 equals 0, and pretend that that 0 is like an x, then what property allows you to write 0 equals 0?
Reflexive.
That's the reflexive property. Okay, now, in the second one, does x plus 0 equal x?
Yeah.
All right, what property is that? It's the identity property of addition. So the second line is the identity property of addition. It transformed the first line into the second line. All right, now, what happened in the third line, in C? you multiplied both sides by, look at C, in 14C. What's different in 14C from 14B?
They added an X in there.
All right, you multiplied both sides by X. All right, what property gives you the right to do that? Multiplication property of equality. Okay, now, what happens in D? How is it different from C?
There's a 0.
You added a 0. How can you add a 0 to a line and not change it? Or why can you add a 0 to a term and not change its value?
Because of
The identity property of addition. So that's how that 0 got in line D. Okay, now what happened in line E? What happened to the X?
It got distributed.
Yeah, so the distributed property of multiplication over addition. All right, and then what about the last one? What did they do to the second X times 0? They got rid of it by dividing. Or, wait, I'm sorry, by subtracting. They subtracted the second X times 0 from both sides, and we end up with X times 0 equals 0, which is the 0 property of multiplication. All right, now, in math theory, that's real important. Well, not an algebra theory, but I didn't say that. Okay.
Therefore, we don't need to do this, right?
Yes, in math, okay, so but anyway, that's what those things are for, is that they're getting you to identify okay, now, so, let's see, let's go back up here. All right, so here is let me double check that. Yeah, okay, same thing. All right, so what you're going to do is you're going to work through those pages, and you're going to do 2 through 34, and in 1-7, the part that we just did, you're supposed to do 7, 8, 9, 11, 12 through 15, and 17 and 18. All right, those are all on the first page. I would tell you this. The odd numbers are in the back of your book. That may help you understand what it is they're asking for. They're asking you to identify the property that allows you to make the change from the line above it to that line. Okay. Last year we didn't do this as strongly as we're doing it this year. So, all right, now let's look. Now we're ready to look at the review. So now let's turn to 44. Okay, on page 44, you're going to do parts A and B of R1, R2, R3, and R4. So now, in R1, that's going to end up being all of it. All right, and this is just identifying the values, the numbers, and the vocabulary. That's what R1 is doing. All right, R2, you're doing A and B. All right, there happens to be more, but you're just doing A and B. Okay, now turn the page. R3, you're going to do A and B. And in 4, you're going to do A and B, which should be all of them. All right, that will get you together on those things. 58, who did that quickly? All right, we got about 20 minutes. All right, any questions on those? I know I went through that fast. Okay, let's do this. Get out a piece of paper. And turn to page 45. And we're gonna work through part C together. All right. So I think I can, I'm going to turn this off. So we're going to work on part C. So, all right, now, what it says to do is to prove that x over negative y is equal to negative x over y. That's the proof. Okay, so the first thing we have to do is that we have to say that x over negative y is equal to x over negative y. All right, for what reason?
Reflexive property.
For what reason? Reflexive property of equality. It's reflexive, because it's the same thing, right? It's always equal. All right, then, the definition of division says this is x times 1 over negative y. That's the definition of division. Okay, now, what am I trying to do? I'm trying to get that negative sign out there. That's what I'm trying to do. Right? Okay, so what's the third step say? It says that x times 1 over negative 1 times y is the same as what we had. Okay, now, what gives me the right to change negative y into negative 1 times y?
They equal the same thing.
What?
They equal the same thing.
All right, it's the property of negative 1 multiplied by negative 1. If you remember, one of the things that you wrote was negative 1 times x equals negative x. So negative 1 times y will equal negative y. We've got the one on the right, we're going to replace it with the one on the left. Okay, now what's the next line say? What they've done is another reciprocal, because this is the same as 1 over this times 1 over this. It's reciprocal, or it's really the definition of division. One over this, and 1 over this. Okay? Now, what do they do next? They group this. All right, that's the associative property, because in this one, these two were grouped, and now we've moved it to the other two are grouped. Then the next thing they did is 1 divided by negative 1, negative 1. You know what that's called? Number fact. That's a number fact. All right, now turn the page. What happened? The x was first. Now we're going this way. All right, what allows me to move it is the commutative property of multiplication. And then you get rid of the negative and go negative x times 1 over y. And that is the multiplication by negative 1. And then we're going to group these two things together with the definition of division and say that equals negative x over y. And it takes all of that in number theory to be able to prove that I can just do it. Okay, now, so if, when I was in college algebra, because I went to college to be a math teacher, all right, this was very important because being able to do this is how you proved that it was legal to do it. All right, but for most cases where you are right now, you need to know that if you have the original problem, where can I put that negative sign? If the negative sign is out here, it's the same as, it's like this, it's the same as, it's like this. That's what you need to know. And the reason that you need to know it is that we could go through that whole process in part C and be able to prove that given this, I can start with the reflexive action that x, or I can start with this, that 1 over x divided by y, I can start with that and I can manipulate it all the way around until I get this. Just like we started with this, manipulated it all the way around and got to this. Right now, how many times do you need to know or memorize that process? Not that often, because you're going in a different direction with your math, but it's there to be able to do. And back when I was in school, that was important. But you know, the dinosaurs, I think, after they died, then we decided we didn't have to do that quite as often. Okay, does that make sense? All right, so that's one of the reasons why you're doing A and B. All right, does that help a little bit? All right. Okay, the second part too is that because you're doing all this work at home, this is not simple to do. To be able to identify those things, because we don't use them often enough for us to be able to identify them. When I taught the Algebra 1 class, the honors algebra for 8th to 8th graders, we spent about 2 weeks on properties so that they could see it and identify it. But in this class, we don't spend 2 hours on it. Right? And so that's one of the reasons why that makes this a little bit harder. Okay? All right, now, after you look at that, all right, in this particular chapter, we've had all review the main items that I need for you to remember. I can't write on that. Okay, if the solution set is 1, -3, what were the binomials? Okay, this is a test question. All right, what do you have to do? What does x equal?
X equals 1.
X equals 1, write it. Write it. X equals 1. And then make it equal to 0, 1 minus x. Or, I'm sorry, x minus 1 equals 0. What's the other one going to be? X equals -3, so the other one is going to be x plus 3. So, if this is the solution set, these are the binomials that go with that solution set. Okay? So, what happens if the solution set is
X plus 5 or -4.
all right. Now this one we may have to write. So it says x equals 2/3 multiplied by 3, subtract the 2, and then -4 over 5, x equals -4 over 5, multiplied by 5, and get 5x, add 4, right? And we will then be able to find the parabola location if we do the multiplication on this, so we can end up finding the parabolas that represent those two things, or we can put it in y equals on our calculator and let the calculator draw it for us. That's where we're headed, okay? Does that make sense? So, solution set, and being able to make binomials out of this one, and if you can make binomials out of that one, then you're at the top of the class. Okay? 4:09, we've got 10 minutes. Anything else? Anything else? I'm sorry I didn't have that test for you. I know you're all heartbroken, right?
Yeah.
Okay.
I cried myself to sleep.
So,
Yeah, it sucks. So like,
yeah, all right, you know, complain all day, right? Okay. All right, now let's look at, ooh, look out, don't get hurt. Okay. What is the name of A? What is it called? What kind of expression is it? All right, first, let's say it loud. It's a binomial. Okay, that's the term. What about the degree?
cubic.
Cubic. So this is a cubic binomial. All right, what about B?
It's a trinomial.
It's a trinomial. Okay, what degree?
8.
No,
Or it's
Sorry.
each term. The highest term is 5.
so the fifth degree.
So it's a quintic trinomial. Okay, now, the last one is what? All right, how many terms? So it's a 5-term, what degree?
6.
So it's a 5-term polynomial of degree,
6.
no. How many exponents do you see in each term? What's 6 plus 2?
Oh, 8.
What's 5 plus 3?
8.
What's 4 plus 4? What's 3? So this is an 8-degree 5-term polynomial. All right, 5-term polynomial degree 8. And the part C is the higher level skill. And the reason that I'm showing this to you is that in B you use the highest term that you have. In this case, it's the one with the 5 exponent, so this becomes a quintic. But when you get into some more elaborate types of polynomials, most of the time the polynomial terms have the same degree. All right, and so this is very normal in higher math. Okay, and then, all right, what's the first term when you multiply these out? Multiply those out. What's the first term going to be?
5, 6, 6 squared.
Oh my, not 5. Multiply.
Josh.
Huh?
6x squared.
6x squared. All right, what's the last term going to be? Negative 28. All right, you'll write those down. The inside and outside have to be added together. So the inside is negative 8x, and the outside is positive 21. And so I guess that's going to be 15? No, 13.
Yeah.
13.
I mean, 6.
13x. But I don't have my calculator with me, so it's 13x. Right? Okay. See, last period, I could put a wrong answer up. So if I didn't know, I'd just throw up any answer, and they had to tell whether or not it was true or false answer that I put on the board. I
Was
can't
that
do
tier
that.
1?
Hmm?
Was that tier 1 or? Yeah.
No, it's that was Algebra 1. Okay, so here we have monomial, binomial, trinomial, and then polynomial of like terms. And then we have linear, quadratic, cubic, quartic, and quintic is the 5. Not everybody's using quintic anymore. All right, so we've already been through that. All right, so we've got everything. Oh, here's the last one. dual inequalities. Whenever you have absolute value, all right, I taught this last year, you're going to take, because it could be positive or negative, you're going to take the value of the positive value here, and you're going to put it on the other side as negative, and then you're going to copy the sign that's here. And it doesn't matter whether it's an inequality or whether it's an equation. That sign gets copied here, pointing in the same direction. Same sign, opposite number. And then you solve these three terms together. So what's the first thing to do to get rid of the 20? You subtract 20 from all three sides. And then you divide all three parts by 5, and you'll have x in the middle, and then you'll have numbers on the outside, and it says x is less than whatever this number turned out to be, and then you say x is greater than whatever this number turns out to be, and it'll end up looking like this. It'll end up looking like this. Here's an example. Absolute value of 2x plus 3 is greater than 7. So I copy the sign, and then I make the opposite of negative 7, because the absolute value could have been positive 7 or negative 7 inside here. Then I'm going to subtract 3, I'll get 7, negative 10, divide by 2, so now I have this. And it says x is greater than 2, x is less than negative 5. Now, here's my question. Is this the part of the graph that makes this true? Where is x greater than 2? It's out here. Right? Where is x less than negative 5? It's out here. Right? And so this particular graph changes to, instead of being one solid part, it's two, and you're on this side or you're on this side. All right? But you've got to be careful to read this correctly. All right, and we've been through that. We've been through all of that. Okay, so we're done, and it is now 16 after. So I'm going to say that you're done and I'm done. I do not like changing. Because I
It's just so
can't,
much easier for us to do, right?
I can't set up and be ready for, I've got to come in here and try to get ready, and it's not working well. Oh, all right, turn that off, please.
Oh,
Yeah.
what's the
Silver thing right there. Yep.